Hello fast learners, welcome to our YouTube channel where we bring knowledge closer to you by just a single click button. Don't forget to like, comment, subscribe on our YouTube channel. My name is Katega James. Once again, I'll be taking you through operations research. Like earlier before, we looked at operations research, what is involved with operation research when it comes to different fields. Therefore, this time around, we are going to look at tools and techniques used in operations research. So, when it comes to operations research, this uses what we call suitable tools and techniques available. There are techniques available when it comes to operations research. And the commonly used techniques or tools, they are either mathematical procedures, cost analysis, or electronic computations. Therefore, one needs to know that operation research is given special importance in that it can help us, the researchers, in order to develop and use techniques like linear programming, game theory, inventory models, and simulation. So those are some of the techniques we may use. So it gives us the ability to experience, to explore more about when it comes to solving problems. So one needs to know that among those above tools I've mentioned, linear programming, game theory, inventory models, and simulation, there are other tools that may be put into consideration like nonlinear programming, integer programming, dynamic programming, sequencing theory, Markov process, network scheduling, symbolic model, and information theory. Also, value theory may be put into considerations. So what are these different tools or techniques when it comes to operations research in details? We have linear programming. So when it comes to linear programming, this is constrained to the optimization. This is a constraint. It's a constrained optimization technique. What do we mean by optimization technique? It optimizes what we call some of the criterion within some constraints. And one needs to know that linear programming, it has an objective function. What is the objective function when it comes to linear programming? One of the objective functions, we have profit, we have loss. One can refer to it as return on investment. And we need to know that such constraints are linear. That is linear programming. Then we have another technique referred to as game theory. When it comes to game theory, this is used when making decisions under conflicting decisions or conflicting situations. We need to know that under conflicting situations, such as when we have one or more players, maybe opponents, maybe in a game. So the success of one player tends to be the cost of other players. Hence, it is a conflict. So this technique specifically deals with conflicting problems. Then we have the decision theory technique. When it comes to the decision theory technique, this is concerned with making decisions under conditions of complete certainty about the future outcomes and under conditions such that we make some probability about what will happen in future. That is the decision theory. Then we have the queuing theory. Q-U-E-U-I-N-G, queuing theory. So when it comes to the queuing theory, this is used in a situation where the queue is formed. For example, you may have customers waiting for a service. Maybe there is Airtel, there is mobile money. So that is a service. So once customers are waiting for a service, then we refer to it as a queuing theory. We may talk of aircrafts waiting for a landing. We may talk of jobs waiting for processing in a computer system. Those are different scenarios where queuing theory might be applied. The objective here is that we minimize the cost of waiting without increasing the cost of servicing. That is the queuing theory. Then we have what we call the inventory models. When it comes to inventory models, this makes decisions that minimize total inventory. We have what we call, in simple terms, inventory specifically means something in stock. We might have goods in stock, that is inventory. So this model successively reduces the total cost of purchasing, carrying, and out of stock inventory. So that is inventory model. Then we have what we call simulation. Many of you know what is simulation, whereby you carry out a procedure that is very impossible to happen. So, simulation is a procedure that studies a problem by creating a model of the process involved in the problem, and then through a series of organized trials and error solutions to attempt to determine the best solution. That is all about simulation. We need to know that when it comes to simulation, it is difficult and sometimes it is time consuming, because it is a process that is very slow, that needs to identify errors in order for it to happen. Therefore, simulation is used when actual experimentation or solution is not possible. Like I've said, that is the simulation technique. Then we have nonlinear programming. Nonlinear programming is used when the objective function and constraints are not linear. Like I've said in linear programming that the constraints have to be linear. We've looked of profit and the return. So when it comes to the nonlinear programming, the objective function and the constraints should not be linear in nature. Linear relationships may be applied to approximate nonlinear constraints, but limited to some range, because approximation becomes poorer as the range is extended. That is nonlinear programming. One needs also know that nonlinear programming is used to determine the approximation in which a solution lies, and the solution is obtained using linear methods, like we shall see. We are going to see calculations when it comes to linear programming. Then we have another technique referred to as dynamic programming. Dynamic programming is flexible in that it is used for analyzing multi-stage decision processes. Whenever you have a bulk of decision processes, then you need dynamic programming. In each elementary decision, when it comes to dynamic programming, it depends on those preceding decisions as well as the external factors. That is dynamic programming. Then we have integer programming. Integer programming deals more with integral values. How? That if one or more variables of a problem take integral values, only then dynamic programming method is used. What do we mean here? That if you have the number of motor cars in an organization, you have number of passengers in an aircraft, number of generators in a power generating plant, that is integer programming. You are dealing with integral values, number. You are dealing with number especially. That is integer programming. Then we have what we call the Markov process. The Markov process, this is a process that permits to predict, to forecast the changes over time information about the behavior of the system, if at all it is known. What do we mean here? Such a process is used in decision-making situations, whereby we need to know that various states have to be defined. For example, the probability from one state, for example, if you are from, for example, let's look at America. There is different states. Maybe let's look at California and let's look at New York. Those are the states. So the probability from a state to another state, if at all it is known, and depends on the current state, and is independent of how we have to arrive at the particular state. I repeat, when it comes to the Markov process, this is used in decision-making situations where the various states are defined. Maybe we have New York, we have California as the states. The probability from one state to another state is known and depends on the current state, and is independent of how we have arrived at the particular state. That is the Markov process. Then we have network scheduling. When it comes to network scheduling, remember, network is a connection of two or more. It may be staff, it may be equipment, it may be offices. So when it comes to the network scheduling, this is used extensively to plan, schedule, and monitor large projects. For example, we may have a computer system, for example, a computer system installation, that is a network. We may have a construction network, we have a maintenance network, and so forth. What is the main aim of network scheduling? The main aim of the network scheduling technique is to minimize trouble spots. What do we mean by trouble spots? Trouble spots are like limitations. They're like backlogs to a system. So they may include delays, they may include interruptions, they may also include production bottlenecks. That is network scheduling specifically does with trouble spots, minimizing them to the core. Then we have what we call information theory. Information theory, this one is an analytical process. It's an analytical process whereby it is transferred from the electrical communication field to the operations research field. And we need to know that when it comes to the objective of this theory is that it evaluates the effectiveness of the flow of information within a system. Many of you study what we call information systems when it comes to computer technology. That is where information theory may be applied. Those are some of the techniques or tools that are used in operations research. We are to look at different calculations when it comes to operations research using or involving such techniques. We shall see calculations in linear programming, whereby some of them will be graphical, others will be through mathematical procedures. Let's look or let's touch on the applications of operations research, because you need to know what are the different applications of operations research. We have accounting. Operations research deals with things like assigning audit teams effectively. That is operations research. It deals with credit policy analysis. It deals with cash flow planning, in and outflow of money. That is operations research. It does with developing standard costs. It does with establishing costs for byproducts. So that is operations research and accounting. We have constructions, projects involving construction. We see things like project scheduling, monitoring and control when it comes to operations research and construction. We look at determination of proper workforce. We look at development of workforce, allocation of resources to projects. That is construction and operations research. We have facilities, facility planning as one of the applications of operations research. Facility, in that we look at factory location size decision, we look at transportation loading and unloading, we look at warehouse location decisions. That is facility planning. We are trying to plan for an industry with respect to operations research. Then we have finance. When it comes to finance, we look at building cash management models. We look at allocating capital among various alternatives, because finance, we are dealing with money especially. We look at investment analysis. Then we have other applications like manufacturing, where we look at inventory control. We look at market balance projection. We look at production scheduling. We look at production smoothing. So all those are under application of manufacturing within operations research. We have marketing. Marketing, in that this time round we look at production mix, selecting the production mix. We look at the production introduction timing. That is, what time does a product take during manufacture to the final delivery? That is marketing application. Then others, we may look at organization behavior, human resources. Human resources, especially when we are dealing with humans. That is operations research. Purchasing. How do you purchase goods? That is operations research. We also look at research and development and operations research. So those are the different applications when it comes to operations research. However, they are applications, but we may also have limitations of operations research. They are to some extent where operations research becomes a hindrance, where it does not apply. For example, we may have limitations like distance between the operations research itself. What is the gap between the operations research, the specialist, and the manager? That becomes a limitation. Whenever the distance is large, there is no gap, there is no bounding gap between the operations research and the team. Then operations research ceases to fail. Magnitude of calculations. We are going to see that the calculations are a bit complex and bulk and hard. That becomes the limitation of operations research. We are going to look at money and time costs. Operations research requires money. It requires investment. It requires costs have to be incurred when it comes to operations research. We're going to look at non-quantifiable factors, things that can't be quantified. You can't put them into measurement. Then operations research tends to fail. We are going to look at how does it implement. Implementation may also become a hindrance because many researchers don't know how to implement operations research. That is going to be all we are going to be looking at when it comes to operations research. Thank you for listening. Don't forget to subscribe to our YouTube channel for more information videos. Thank you very much. We love you. Don't forget to subscribe. Don't forget to comment. Thank you very much.